Now this ice feature here, when we excavated, this ice feature was exposed and immediately became a fan favorite. And I don't know if you're gonna capture it well enough for everybody to see, but we have a researcher who's from West Virginia, and she says it looks like Mothman. Now,
I'm not sure. Mothman?
Mothman. I don't know who that is. I haven't really cared enough to look it up, if we're being honest. But what people see, Jesus on a cross, an angel, a whale tail, an ant head. These ice features are kind of like cloud animals. What you'll look at it and everybody sees something different. But what I can tell you this really is this is an ice wedge, and this top part here in this V of dirt is something called thermokarst cave ice. So this was a subterranean water flow that cut this ice wedge, deposited this V of dirt, and then refroze here.
Right.
Okay, now here's another example of that shows just that stark comparison between the brown ice of the ice wedge and the clear ice of the thermokarst. When this came through, all of this sediment that makes this little upside down mustache here settled out, and then this water refroze here. And we look down here, we see the same thing again. It happened lower. It's not quite as clear, so obviously this refroze quicker before everything could settle out of it. But this is pretty awesome. That's pretty.
That is really, oh, wow, you can see. And so the quality of the ice, what's mixed in the ice? I mean, just mineral composition, or is it?
Yes, they have. Do I know it? No. Okay. Yeah, I mean, you're going to see, especially not this so much, some thermokarst that we have further back, they have like a higher, there's like some iron oxide, so it's red, but there's some sodium in there, so it's kind of melting a little bit faster.
And have they measured any of the gases, like CO2
Yes.
and methane? So
yeah, so they've carbon dated the gases that are in these. You know, they take a core sample and they carbon date the gas that's in the bubbles.
Right. So they'll know essentially the kind of concentration at a certain level of CO2. And if it were to ever, I don't think this will never probably thaw. I mean, this is just too deep. I mean, what's your, this is.
Yeah, we're probably 20 feet deep.
Yeah.
But, the problem that we have, our impact on this, I showed you that dirt road, that gravel road.
Right.
Now imagine putting a nice thick band of asphalt on there to really focus that solar energy. And we have a real problem here with our roads. Literally, in the summertime, from 1 week to the next, you'll definitely detect in your suspension where the permafrost beneath it is thawing and the road is literally falling.
But even at this depth?
Remember the Linnell plots, they went 10 meters down just by removing the organic matter. So if you remove the organic matter and put asphalt on top, then yeah.
Perfect storm.
Yeah.
Yeah.
I mean, that's 10 meters, so 33-ish feet, and we are not 33 feet deep right here. This is only about 20 feet below ground level.
Wow.
So yeah, easily this could deteriorate.